Hey guys, and welcome to this video on function notation. Let's get the show on the road. Alright, let's consider the following function named John, and we have an equation for this function. That the output equals twice the input minus 5, or y equals 2x minus 5. And in front of us we have three questions, and all we're asked to do is to find the output to this function if the input were 6, if the input were -2, and if the input were 18. And in each case, all we have to do is substitute that value in for x and find the corresponding y value. So why don't you pause the video, do that, and make sure to write each of these input-output pairs as ordered pairs, and then unpause the video and we'll reconvene. So, in each case, we might say, when the function John is applied to the input 6, the output is 7. When the function John is applied to the input -2, the output is -9. When the function John is applied to the input 18, the output is 31. What we want to learn about today is that there's another way to write this, and I'm going to show you how this looks. Each of these statements at the bottom mean exactly the same as what we just said. When the rule John is applied to the input 6, the output is 7. When the rule John is applied to the input -2, the output is -9. When the rule John is applied to the input 18, the output is 31. And that's exactly what function notation is. It's just another way of communicating input-output pairs to the reader, but referencing the name of the function while we're doing it. And the way to write function notation is you write the name of the function, and then in parentheses what the input is, and then that equals whatever the corresponding output is. Now, by convention, when we see an expression like John parentheses 12, it's a little inconvenient to have to say the rule John evaluated at the input 12 again and again. So we shorten this statement and we simply say John of 12. Likewise, if we saw something like Betsy parentheses x, we could just say Betsy of x, where Betsy is the name of the function or the rule, and x is just a variable to represent our input. So now below we're asked, please find the output when the rule John is applied to the input 12, or we could similarly call this John of 12. And all we do is we substitute 12 in for our input variable and evaluate. So John evaluated at 12, or John of 12, would simply be 2 times 12 minus 5, or 19. And we would end up with John of 12, or the rule John, when applied to the input 12, gives an output of 19. And we could write it as an ordered pair as well. I just want us to be very comfortable going back and forth between ordered pairs and function notation. Our second question asks us, please find the output when the rule John is applied to the input 9/2, or simply said, John of 9/2. Same idea. 2 times 9/2 minus 5 for a grand total of 4. So we might say John of 9/2 is 4. 9/2 comma 4 being the ordered pair. Or John of -7 would be 2 times -7 minus 5 for a grand total of -19. And so John of -7 is -19, and we'd write that as an ordered pair as -7 comma -19. Now, we can have any number as an input and find the output, so we need a general way to write John's rule using function notation. And instead of using y to represent the output when the input is x, we would simply say John of x equals 2x minus 5. The output when the rule John is applied to the input x is 2x minus 5. These two right here are absolutely synonymous statements. It just means to find your output, take your input, whatever that input may be, multiply it by 2, and then subtract 5. For all of the other times we used function notation so far, we've gotten specific examples of input-output pairs. This general notation up here doesn't give us any specific input-output pairs, but it does tell us the rule and the way to get input-output pairs using specific values. So now we've got our function John's equation written in function notation. This says that the output is going to be 2 times the input minus 5. And so now let's handle some of the similar questions that we have before, but using function notation. Well, the first question asks us, if the output to this function were negative 11, what would the input be? And we're going to do the exact same thing that we did before. We're simply going to substitute the output with negative 11 and solve for the input. So we have negative 11 equals 2x minus 5, and now we've got an equation that I'm wholly confident we can solve. So we see that when the input to this function is negative 3, the output is negative 11. One little note, we're used to looking at these ordered pairs and visualizing them as x comma y pairs. But now another way to think about this is that they're input-output pairs, so they're x comma John of x pairs. Note that this right here just means the output when x is the input, and that's the same thing that the y meant before. In the second example, we're asked, well, if the function John operates on some input and the output is negative 17, what's the input? So we just substitute negative 17 in for our output to find our missing input. So negative 17 equals 2 times r minus 5. If r is the input, what's the output? And once again, we have a very easily solvable equation. So we see if that the input were negative 6, then the output would be negative 17. Similarly, for this last question, we're asked what input, when the function John operates on it, will give an output of 21. Well, all we're going to do is substitute 21 for our output and solve for our missing input. 2 times r minus 5. And once again, we have a very easily solvable equation. So the missing input in this case is 13. Now note that all three of these questions are exactly the same question, just with different numbers, but the second two are asked using function notation. So I wanted to show how these types of questions parallel each other, even though they may look a little bit more confusing. Alright, let's consider a new function, whom we're going to name later. In this case, w is going to be our input, b is going to be our output, and this function's equation is negative 2w plus 7b plus 28 equals 0. Now what we'd like to do is write this function in function notation. But right away, the first thing we need to know is, in order to write a function using function notation, we must rearrange the equation into output equals form. Right now we're not in that form. So why don't you pause the video, put this in output equals form, and when you do so, press play and we'll reconvene. So now that we have our function in output equals form, now we're ready to put this in function notation. Now, whatever name we like to use, we would write this as name evaluated at the input w equals 2/7 w minus 4. Now, of course, the input could be anything, and that's why we use a variable here to represent it. Now, so far, we've named our functions nice things like Betsy and George and Bob and Ernest. But the name for a function that many mathematicians use is f. So let's practice using that function name right now. So we would call this function f, and we would write this as f of w equals 2/7 w minus 4. So whenever we see the letter f, it is most likely not a variable. It is actually the name of a function. Two other names that mathematicians also give their functions are g and h. So just be wary if you see an f or a g or an h, it very well may be the name of a function and not a variable. And note, when you see this f of w right here, there is no multiplication going on. F is not a variable. It is the name of that function's rule. So very important to keep those things straight. Now that we have our function f's equation in function notation, now we're ready to go and do things like find f of 4, which just means find the output when the input is 4. And all we're going to do is we're going to substitute 4 for our input variable, w. And we end up with the output when the input is 4 will be negative 20/7. Or we could find f of 14, which just says please find the output when the input is 14. And we're just going to substitute 14 for w in our equation. And we find that when the input to this function f is 14, the output is 0. We could also be given the output, in this case negative 8, and have to find the input that will give it. In exactly the same way, we're just going to substitute negative 8 for our output, leave our input as a variable, and solve. And we find that if the input were negative 14, then the output would be negative 8. Last example, we could find out what the input would have to be so that the output were 9. So all we do is substitute 9 in for our output, leave our input variable as a variable, and solve. And we see that in order for our output to be 9, our input needs to be 91/2. One thing to note is that when we're writing our function's rule in function notation, we may use any variable to represent our input. So for instance, the following statements all mean the same thing. Whether we're using the variable w, or the variable x, or the variable m to represent our input, each of these statements mean the exact same thing. They mean f's rule is take your input, multiply it by 2/7, and then add negative 4 to that in order to get your output. Alright, now to finish up with a little practice. Here's a function, g of x equals x squared minus 6x plus 9. Note to self, g is the name of our function, while x represents our input variable. And we've got 6 examples where we're asked to find the output when different things are the input. And for each one of these, all we have to do is substitute that input for x everywhere it appears in our function's equation. So here and here. And if, like in the first 2 examples, we have an actual number, I'd like you to find the numeric output. For the last 4 examples, we've got some symbols we have to deal with. So we're going to substitute those in for our input, but we might not be able to find an actual numeric output. We might have to keep the output in variables. So please pause the video, give these 6 a try, and when you're done, unpause the video and we'll see how it went. Alright, as we said before, in only the first 2 examples could we actually come up with a numeric output. For the remaining 4, we had to leave our outputs in symbolic or variable form. Alright, one more practice problem. Here we've got our function m of x equals 4x plus the square root of x plus 1 minus 3. Note, m is the name of our function and x is our input variable, and we're asked to find the outputs for 4 different inputs, 2 of which are numbers, 2 of which involve symbols or variables. So again, I'd like you to pause the video, try to find these outputs, and when you're done, play the video and we'll check. Alright, so here are the outputs for those 4 respective inputs. Alright guys, that's it for this video. I hope you enjoyed and I hope you found it helpful.